Hey everyone, this is 3 examples of 2 solutions for the ambiguous case of the law of sines. These are the side-side angle triangles. Basically what I'm going to do is, like I did in the introduction video, is just draw 2 triangles when you see that it's a side-side angle, meaning you have a side angle here. Okay, and I'm going to write it in both triangles. So you have 40 degrees, 2 and 3. And if you notice, the side across from the angle they gave you is smaller than the sides of the angle you don't have. So we don't know this side. And this was our gamma that goes with C. And gamma 2 that goes with that. So the first thing we're going to do is find our gamma 1 by using the law of sines. So we're going to do sine, and again, this is just a tutorial, sine of 40 over 2 equals sine of gamma over 3, and you cross multiply and you get sine of gamma equals 3 sine of 40 over 2, which is approximately 0.9642. And so my gamma, it's gamma 1, equals sine inverse, or inverse sine, however you want to say it, and 9642, which equals approximately 74.6 degrees. So I know this gamma 1 here is 74.6 degrees. Now, since there's no angle or anchor here, we have to see if we can make another triangle. And we can, because this video is just about that. But I'm going to see if I have another gamma 2. Well, the gamma 2 is what you do is you take 180 minus your gamma 1, which is 74.6 degrees. And what you get for gamma 2 is, what's gamma 2? 105.4 degrees. If you notice, when you add these two up, so when you add 40 plus, I'm not going to put the degrees, it's hard to do that, this 0.4, that's less than 180. That tells you that you can make another angle here. That means you have 2 triangles, thus 2 solutions. So once you just determine that, you just have 2 problems to do. And what we're going to do is we have to find our alpha 1 and alpha 2, and therefore our A1 and our A2, because we have 2 triangles. Okay, so we're just going to get alpha 1. So alpha 1 equals 180. You just subtract your angles. Minus 40 degrees. These are all degrees. Minus 74.6 degrees. And that gives you approximately 65.4 degrees. And for this one, for your alpha 2, you're going to get 180 minus 40 degrees minus 105 degrees, 0.4 degrees. And that's going to be 34.6 degrees. So this is 34.6 degrees. And then all you have to do is find your A's. So A is going to be sine of beta. So let's do purple now. Sine of 40 over 2 equals sine of 65.4 over your A1, and you cross multiply, and you're going to get A1 equals 2 times sine of 55.9 degrees over sine of 40 degrees. And that gives you approximately 2.83. So this is 2.83. And for this side, your A2 is going to be same thing, sine of 40 degrees over 2 equals sine of 34.6 degrees over your a sub 2. You cross multiply, and that's going to give you a sub 2 equals 2 sine, I'm just crossing up here, 2 sine 34.6 degrees over sine of 40 degrees. And that's going to be about 1.77. So that right there is 1.77. So there's your two triangles. Okay, and we're going to do another example. I'm going to write down the information, and you might want to try it by yourself and then see if you get the same solutions we get. So what we have is B equals 4, C equals 6, and beta equals 20 degrees. So I'm going to go ahead and draw two little triangles here, mainly so I have room. I try to make this side over here smaller, because this side here always has to be smaller than this side. And I'll just squeeze over here and kind of do the same thing. Try to make it a little smaller. Alright, so my beta is 20. The side across from 20 is 4. It's like a 9. That's a 4. And then my C is 6, and I always write it this way. So that's going to be your gamma 1, and we're going to be looking for alpha 1 and my A1. And I'm going to copy the same thing down, 20, 4, 6, but now we have our alpha 2 and gamma 2, because this is my triangle 2. Alright, and now we just solve for gamma 1. So we have sine of 20 over 4 equals sine of 6 over your gamma, and you cross multiply and you get sine of gamma equals 6 sine of 20 degrees over 4, which is approximately 0.5130. So gamma equals inverse sine of 0.5130. So and that is 30.9 degrees. So this is 30.9 degrees. Now, to get gamma 2, we're going to take over here, we're just going to take 180 minus your gamma 1 to see if we have another triangle. And when we do that, we get 149.1 degree. And if you just look at this, we notice that your 20 degrees plus 149.1 degree is less than 180. That means we can form this triangle. Now, to get our alpha 1, all we're going to do is take 180 minus my 20 minus my 30 degrees, 30.9, and that's going to yield 129.1 degree. So that's there. And my and then so let's just go ahead and get my side here. So then we're going to take sine of 20 over 4 equals sine of 129.1 over A1, and you cross multiply and you get A1 equals 4 sine of 129.1 degree over sine of 20, which is approximately 9.08. So that is 9.08. So we filled up that triangle, and now we're going to do this one. We got to find alpha 2. So alpha 2 is 180 minus 20 minus 149, and we're going to get 10.9 degrees. It's 149.1. So this right here is 10.9 degrees. And now we just have to find my A2. So your A2 is just going to be sine of 20 over 4 equals sine of 10.9 over ace of 2. I shouldn't probably put that there. And you cross multiply, and you're going to get your third side here is going to be 4 sine of 10.9 degrees over sine of 20. And so my A2 equals 2.21. So right here, this equals 2.21. And that's our two triangles. Okay, I'm going to do the last one. I'm going to go a little faster. Again, I suggest you try to do it by yourself and then check to see if you get the right answers. You already know it's going to be two triangles. So we're going to do A equals 2, C equals 1, and gamma equals 25 degrees. Now in this case, I'm going to go ahead and draw my two triangles, try to make this side a little smaller. I'm going to put it over here, draw it, and those are, oh my God, that's bad. All right, let me try to do it a little better. There you go. And fill everything in. Now, since they gave me the side and the angle that go across, I'm putting my gamma here. Because if you're just learning this, it makes it a little easier if you keep it in the same position. You can always label your variables differently. So since they gave me my A, this is going to be my alpha 1, alpha 2, and what I'm missing is my beta. So this is 2. Beta 2, and this is going to be B2, and this is going to be beta 1 and B1. And then you just proceed as usual. We're going to do sine of 25 over 1 equals sine of alpha, which is alpha 1, over 2. You cross multiply, and you get 2 sine of 25 equals your sine of alpha, and which is approximately 0.8452. And so alpha is inverse sine of 0.8. My 4s and 9s look the same. That's a 4.52. So your alpha 1 is 57.7 degrees. Now I'm going to go ahead and put it in, figure out if I have alpha 2. And the way you do that is you just take 180 and you subtract your alpha 1 to see if you get an alpha 2. Or see if you're going to get an alpha 2, but see if it works. So we get 180 minus 57.7, and that's going to give you 122.3. it's 122.3. And if you notice here, when you add these two numbers up, they're less than 180, so we have the two triangles. And then you just solve for the rest. So you subtract to get beta 1. You subtract 180 minus 25. These are all degrees. Minus 57.7 degrees. And that's going to give you 97.3. And then you have to find B1. So we're going to get sine of 25 over 1 equals sine of 97.3 degrees over your B. It's not B squared. B2. You cross multiply and your B2 is going to equal, or your B1. Why am I calling it B2? So it's B1. Alright, this is all the triangle 1 here. This is triangle 1. This is triangle 2. Alright, and that's your B1 is going to be 2.35. And then we do the same thing here. We're going to find out what our beta 2 is. Beta 2, oh, this one over here was 97.3. All right, so beta 2 is going to be 180 minus minus your 25 minus your 122.3 degrees. And so your beta 2 is going to equal 32.7 degrees approximately. And then you just use the law of sines again. Sine of 25 over 1 equals sine of 32.7 degrees over what you're looking for, which is our second beta. So beta 2 equals sine of 30, you can put the 1 there if you want, sine of 32.7 degrees over sine of 25 degrees, and that's approximately 1.228. Yeah, so that's going to be equal to 1.28. So there's your two triangles. Okay, the next video I'm going to show is going to be one solution, the ambiguous case with one solution. And I'm also going to draw the two triangles and show you where the one solution happens. Thank you, and have a nice day. Bye-bye.